Okay, this video is going to talk a little bit about scientific notation. And what scientific notation is it's a method of writing really big and really small numbers. So when we take a look at the scientific notation, we'll normally see that it's written in a particular format. We'll have three parts to this. We'll have one number in front of the decimal point, and that has to be a 1 through 9, can't be a 0. So when we take a look at that number in front of the decimal point, then we have kind of the rest of our setup with the numbers after the decimal point. We're going to take a look at this a little bit more in depth in our next chapter when we talk about significant figures. And then lastly, on the end, we have our power of 10. So why do I care about this? Honestly, the reason I like scientific notation is because I hate dealing with zeros before a number and after a number, especially if I have to write that number over and over again. So for example, if I were to have to add something up like 1 million, what I would do is I would just simplify this a little bit. Let's actually simplify this down, change our number a little bit. We'll make it 1.4 million. So what I would do is I would say, all right, I know my decimal point starts at the end of this number, and I'm going to draw my decimal point in red just to help point out our differences here. Whenever I go into a scientific notation, my goal is to have one number in front of the decimal point, or one digit that can't be a 0. So what I do is I move my decimal point over, and I rewrite my number. So in this case, I then went over and made my number smaller, so I have to multiply it by a positive power of 10. And the number of places I moved over is the exponent that I put next to that 10. So in this case, we're going from what we call standard notation to scientific notation. And in this case, I don't have to write in all these zeros because they were just placeholders. So we can do this when we go from a bigger number to a smaller number as well. So in this case, we have a really big number that we're shrinking down, even though they're the same thing. So in this next setup, then, we're going to take a look at scientific notation of small numbers. So these are for numbers greater than 1. And so now I'm going to look at numbers that are less than 1. So for example, something like this. How would I write this standard number in scientific notation? So again, I'd follow the same protocol. When I'm going from left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I move this over, and I rewrite it as 8.72. But now I went to the right with moving my numbers. So what I'm going to do is I'm going to write this as 10 to the -9th. So in this case, this -9 means it's less than 1. And my positive value on my exponent with my 10 to the 6th means it's going to be greater than 1. So let's look at a little bit more practice then, kind of thinking about our protocols here. So we're going to look at 3 examples together. Our first example And we're going to be taking the approach where we go standard notation to scientific notation. And I have 847. I have 623,874.81. And then we're going to have 0.000399. I've given you three numbers in standard notation. So in this case, the question I have to ask myself first, are we greater or less than 1? So in this case, we'll see that this is a greater. I'm going to mark that with the G. Same thing here, we've got greater. And in this example, we have less. So what I do is I move my decimal point over, and this becomes 8.47. And I moved my decimal point 2 times. And since my number is greater than 1, this is a positive exponent, so I leave it as it is. We'll do the same thing here. When I take a look at my number, I move my decimal point so there's only one non-zero digit over. So I can rewrite this as 6.2387481. And then I have to put my times 10 to that to count how many times I moved my place. Moved it 5 places. And since I'm greater than 1, I have a positive exponent. So if I'm greater than 1, I keep the exponent positive. Now let's take a look at this last one here. I have to move my decimal point over, so it ends up being one non-zero digit, and I've moved it 1, 2, 3, 4, 5 times. So I'll rewrite this as 3.99 times 10 to the 5th. However, this is less than 1. If that's the case, I say this is a negative exponent. So with some of these, we'll just have to think about greater than, less than 1, count the number of places I move the decimal to leave one non-zero digit in, and then I determine whether my exponent's positive or negative by going greater than or less than 1. So now let's take a look at some examples about how to go backwards with this idea. If I'm going from scientific notation to standard notation, what I'm going to do is I'm going to look at (4.555) times 10 to the 3rd as our first example, and we'll take a look at a negative example or a negative exponent here. So in this case, what this does is this tells me how many times to move the decimal, or how many places to move the decimal, and if my exponent is positive, what I'll do is I'll move the decimal point to the right. So dp is decimal point. So what I'll do is I'll move this over 1, 2, 3. And then I fill in any additional numbers or any additional places that didn't have a digit. I add a 0. So now, in the second example, we'll see that my exponent is negative. So what I'm going to do is I'm going to move the decimal point to the left. So in this case, I'm going to move this over 1, 2, 3, 4, 5, 6, 7. And I like to put a 0 in front just to make sure I know it's less than 1. And then I fill in all of the missing places with zeros. So when we go from scientific notation to standard notation, we're going to use the basis of the exponent. If I move my decimal point to the right, I do that because there's a positive exponent. It's greater than 1. If I move my places to the left, it's going to be negative, which means it's less than 1. It's going to be a negative power of 10, which says it'll be a value that's less than 1. So how do I add and multiply scientific notation together? You can do this one of two ways. Whenever I do add and subtract, if I have to do numbers in scientific notation, what I do is convert to standard and then do the math. So let's take a look at an example of this real quick. When I'm here with my scientific notation, what I'll do is I'll say, okay, I have this setup where we have 4.83 times 10 to the negative third plus 8.71 times 10 to the minus second. So in this case, I don't have the same power of 10, so I'm going to have to convert them both to standard notation first. So this means I move it to the left 1, 2, 3 places. I move to the left 2 places, and so I can rewrite this. 0.00483 plus 0.0871. Now this makes this a lot easier to do the math. I carry the 1, and then I can rewrite this back into scientific notation, where it's 9.193 times 10 to the negative 2. The last potential possibility that you can see is that you might have to do multiplication and division. So what does that mean? What I do first is I like to say if I have something like 2.87 times 10 to the 5th divided by 1.74 times 10 to the 3rd, what I like to do is separate this out a little bit. I put my 2.87 and 1.74 together, and then I multiply that by 10 to the 5th over 10 to the 3rd. So now what I can do is I can just go to my calculator and I can get 2.87 divided by 1.74, and that simplifies down to 1.65. And now I can rewrite that. There we go. And now I know that 10 to the 5th divided by 10 to the 3 is 10 to the 2. And so I can rewrite my numbers here. I figured this out based on our exponent rules. If I divide my exponents to the same base, you can subtract. Multiply the exponents with the same base, you can add them together. So just a little bit of a review. You can also do this on your calculator. What I'll try to do is I'll try to draw up a quick video of me using a couple different examples, and I'll try to have that up by Tuesday at the latest for you.